This video is going to go through the concepts of arithmetic and geometric sequences. We've already talked about these, but we're going to talk about them in more depth and look at some more challenging problems that have to deal with arithmetic and geometric sequences. So if you recall, an arithmetic sequence is a linear function, and the reason it's called arithmetic is because there's a common difference between each of my terms, meaning if I have a term, actually a sequence that looks like this. So I've got, I'm adding a common difference. I'm adding 2 every time. So that's why it's called arithmetic, because I'm adding it every time. I could also be subtracting, which would be adding a negative number each time. Notice that it also says it's a linear function with a domain of a positive, that are positive consecutive integers. So if you recall, domain for arithmetic and geometric sequences, we talk about the first term, the second term, the third term, the fourth term. So if this is my domain, then I would have to start with 1, then 2, then 3, then 4, because I have to start with the first term, then the second term, then the third term. I don't have term number 1 1/2, term number 2 3/4. So it has to be positive and it has to be consecutive integers. If you recall, a geometric sequence is an exponential function because each time I'm multiplying. So for example, if I have 2, 4, 8, 16, this would be an example of a geometric sequence because I'm multiplying by 2 every time. So notice here, when I multiply by 2, this only goes up by 2. Then when I multiply by 2 again, it goes up by 4. So this rate of change is not staying the same. That's why it's exponential, whereas here my rate of change, it's constant. It's 2, then 2, then 2, then 2, then 2, then 2, then 2, and it stays 2 every time. So that is my slope, or my constant rate of change for a linear function. We're going to talk about the formulas, the explicit and recursive for each, but first we're going to go over arithmetic and several problems that deal with arithmetic. The explicit formula, if you recall, is used to find a specific term in the sequence. So when it says the nth term, it means the 15th term, or the 100th term, or the 27th term, whatever term you're looking for. So in this case, this would represent my nth term, whichever term you're looking for. You may be given that term. This a sub 1 is my first term in the sequence. D is my common difference. And then N is my term number, or my number of terms, depending on how it's worded. If you recall, the recursive formula is not quite as useful, but we still need to know what it is. And it's used to find the next term, but you have to know the previous term. So in this case, I need to know the first term, but then I can also find the 500th term if I wanted. In this case, if I was looking for the 500th term, I would need to know the 499th term in order to do that. So this is still my nth term. This would be the previous term, or the term before the nth term. And then this is my common difference. Alright, so let's look at some examples. So it says to find the common difference, write the explicit formula and find the 10th term for the following sequence. So let's look at this. If it didn't tell us it was arithmetic, I could find that out just by looking at it and seeing, is it being multiplied by something every time or adding something every time. So here I'm adding 6 every time, so my common difference is 6. And then let's go ahead and write the explicit formula. If you recall, remember that formula on the previous slide looks, plus, like this. So we're going to plug in what we know. We don't know the nth term. We know the first term is 3. We know the common difference is 6. and we don't know the term number or the number of terms, we're just writing a formula. I'm going to simplify this. Sometimes you'll see it left like this, but oftentimes they'll simplify it. I'm going to distribute, and I get 6n minus 6. Combining like terms, that simplifies to be 6n minus 3. Now notice this is a linear function because we basically have y equals mx plus b. Alright, now it asks me to find the 10th term, so I'm going to plug in my n value of 10. So I'm looking for the 10th term. I'm plugging it into this one because it's just faster. I could plug it straight into here, but let's go ahead and plug it into this formula. So I end up with 6 times 10, which is 60. 60 minus 3 is 57. So the 57th term is 10. Now let's say they didn't ask us to write out this formula and simplify it first before we found the 10th term. In that case, basically you would just be plugging in 10 right here. So that would look like this. I know the first term, I know the common difference, I know I'm looking for the 10th term. So you would just simplify this, and that also simplifies down to 57 as well. This one asks me to write a linear function that corresponds to this sequence. Basically, it's asking me to do the same thing I did right here. So I'm going to plug in what I know, and then I'm going to simplify it. Looking at this, my common difference, it's going down by 7 every time, so I'm subtracting 7. So when I plug that in, I end up with my first term is 8. My common difference is negative 7, and then I've got n minus 1. So I'm going to distribute that negative 7, and I end up with a sub n equals, if I combine like terms, it's negative 7n plus 15. And if we wanted to write it in function notation, since it asks us to write a linear function, we could just replace that with f of n. But I would be fine with you leaving it like that. Alright, this gives us a recursive formula. Remember the recursive formula again is to find a certain term, you have to know the term before it and then add the common difference. So we know the common difference is 5. And it tells us the first term is 29. It asks us to find the first 5 terms of the sequence, write an explicit formula, and then find the 15th term. So we'll do those in that order. The first term they give us, so that's 29. And really I don't need the formula because I'm told that the common difference is 5. So to find the next term, all I would have to do is add 5. Find the next term, I'm going to add 5 to the previous term. Keep adding 5. And those would be my first 5 terms. Then it asks me to write an explicit formula. So I'm going to plug in what I know into the explicit formula. Remember, this is recursive. So my first term is 29. My common difference is 5. And I'm plugging in those two values. When I simplify that by distributing my 5, I've got 29 plus 5n minus 5. So that simplifies to be 5n plus 24. And then again, to find the 15th term, I can plug it in here. I could plug it in back up here, but this is just faster. So if I'm looking for the 15th term, I'm going to plug in 5 times 15 plus 24. This gives me 75 plus 24. So my 15th term is 99 when I add those together. Here I'm looking for the 25th term. So I'm going to plug in what I know into this formula. I'm looking for the 25th term, plugging it into the explicit formula. I know my first term is 20. They give it to me right here. I can see that it's going down by 6. So that means my common difference is negative 6. And I'm looking for the 25th term. So 25 is going in for n here and n here. So the 25th term, I'm going to simplify this. 25 minus 1 is 24. When I multiply negative 6 and 24, I get negative 144. When I add positive 20 to that, I end up with a negative 124 as my 25th term. To find the 18th term in the sequence, I'm going to do the same steps I did up here, this time plugging in 18. My first term is 3. My common difference, if you see, I'm adding 9 every time. And then 18 is my n value, my term number that I'm looking for. Oops, sorry. So I've got 9 times 17, which gives me 153. So 3 plus 153. And I add that, I get 156. So my 18th term in this sequence, if I were to list all these out and get to the 18th term, it would be 156. Alright, again, we're finding explicit formulas for this, so we're plugging in what I know. That means my answer, if it's looking for a formula, my answer is not going to be a specific number, it's going to be a formula. So a sub n, that means my n's will still be in my formula. First term is 3, common difference is 11, and then I just have to simplify it. I'm just distributing my 11 and adding like terms. So I've got 11n minus 8. Next, I have, and I would encourage you to pause this and try all these and then play it back to see if you got them right. First term is 48. Common difference this time is negative 8. And then I've got n minus 1. Distributing that, I have 48 minus 8n plus 8. If I add 48 and 8, I get 56. So my formula is negative 8n plus 56. This one, I'm going to go ahead and do this up here. My formula for this, I've got my first term is 5. My common difference is 6. And then distribute, combine like terms, and I get 6n minus 1. And again, looking back, all of these are linear functions. Alright, this one is working a little bit backwards. It's asking us to find the first term, and it gives us the 8th term. So if you recall, let's go back to this general formula. Okay, it tells me that the 8th term is 36. So I have a specific term number. It's the 8th term, but the actual value of it is 36. So that is my nth term, because the 8th term is 36. My first term is the one I'm looking for. They tell me the common difference is 2, and then n gets replaced with 8 because it's the 8th term that I'm talking about. So this is where some people get confused, is which one goes where as far as the 36 and the 8. So remember that this is the number of terms, and we're talking about 8 terms, and then this would be the specific value of a given term, and that is 36. I'm going to simplify this and solve for the first term. I have 2 times, that's going to be 7, so that'll be 14, 2 times 7. Subtract 14, and I end up with a first term of 22. For an arithmetic sequence, the first term is 2, and the common difference is 3. 59 is a term in the sequence. What term number is it? So we're looking for a term number, which means we're looking for n. Alright, so it tells me my first term is 2, my common difference is 3. We're looking for n because we don't know what term number it is, but we know that the value of the term is 59. So we're looking for the term number. So I'm going to simplify this. I end up with 3n minus 3. 59 equals, I'm going to combine like terms, -1 plus 3n. Add 1 to both sides is 60. and then divide both sides by 3, and I end up with an n value of 20. So that means that 59 would be the 20th term in that sequence. This one, what term would 93 be in the sequence, is basically saying the same thing. We just have to find the first term and the common difference without them spelling it out for us. So 93 is the specific term value that we're looking at. My first term is 5. My common difference is 8. But we don't know what term number 93 is. I'm going to simplify this by distributing my 8, so I get, plus 8n minus 8. Combining like terms, I have negative 3 plus 8n. Add 3 to both sides and I get 96. And then 96 divided by 8 gives me 12. So 93 would be the 12th term in this sequence. For an arithmetic sequence, the first term is 7, and the 52nd term is 211. What is the common difference? So again, I'm plugging in what I know and solving for what I don't know. So I know that the first term is 7. The 52nd term is 211. So 211 is the value of a specific term. I'm looking for the common difference, but we know that it's the 52nd term that I'm talking about. So 52 goes in for my term number. Simplifying this, 52 minus 1 is 51, so 51d. Subtract 7 from both sides, and I end up with 204 equals 51d. And 204 divided by 51 is going to be 4. So the common difference in that sequence that we're talking about would be 4. Given a term and the common difference of an arithmetic sequence, find the first 5 terms and the explicit formula. So we're given the 40th term, so that means that the specific value of the 40th term goes here. I don't know the first term. I know that the common difference is negative 30, and I know I'm talking about the 40th term. So I've got negative 1191 equals the first term, which we don't know, plus negative 30 times, what's that, 39? So that's going to give me 1170, negative 1170. If I add add 1170 to both sides, that gives me negative 21 for my first term. So my first term in my sequence is negative 21. And now I can find the first 5 terms because I know the common difference in the first term. And then I can also write the explicit formula. So the first term is negative 21. The second term, if I subtract 30 from that, would be negative 51. If I subtract 30 from that, would be negative 81. Subtract 30 from that, 30 from that, it would be negative 111. Is that right? Yes, negative 111. And then subtract 30 from that, and I get negative 141. So those are my first 5 terms. I just took the first term that I found and then used my common difference to find the first 5 terms. And then finally, write the explicit formula. So I've got my first term that I found, which was negative 21, my common difference of negative 30, and n minus 1. Remember, when I'm writing a formula, n is left in my answer. I don't have a specific value. So I end up with negative 21 minus 30n plus 30. And I ended up with, when I combine like terms, I end up with negative 30n plus 9. Alright, here it asks me to find this specific term. So let's look. This is to be the first, the second, the third, the fourth, the fifth, the 6th term. They're looking for the 6th term. And they give me the first and the 9th term. So let's find our common difference. and then we can figure out which term, what this term is. So I got the first term, which is 1, plus my common difference, which I don't know, and then I'm going to use this term because it's the only other information I have. So it's the 9th term, and the specific value of that 9th term is 46. So I've got 46 equals 1 plus 8d. Subtract 1, and I end up with 45. Right? Yeah. And that doesn't end up being a whole number. Let me pause it for just a second. Okay, so apparently this is just a bad example. Obviously if this was being divided by 9, that would work much nicer. But anyways, whatever your common difference that you would get, which would be a whole number, I mean, you could use, your decimal. In this case, it's not a pretty one. But you could use your decimal and add it. But let's say, hypothetically, my answer was 2. Then basically I would just add 2 and fill in these blanks until I found the correct term that I was looking for. So sorry about that. Alright, so we're writing the explicit formula for each of these graphs. And if you recall, they should be, if we're talking about if we're talking about arithmetic sequences, they should be linear. So notice these are all graphs of lines, except that, remember we talked about their domains are integers, so that's why they're not actually connected to make a line, because we have to have our first term, our second term, our third term. We don't have anything in between. So in this case, basically we're looking at writing a linear function for this, if we're using our explicit formula, you could do it by just looking at each of these. The first term is 14, the second term is 10, the third term is 6, and the fourth term is 2. So if you look at each of these values, you'll notice I'm going down by 4 every time. So my common difference is going to be -4, and then my first term is 14. So all I have to do is simplify that, and I would have an explicit formula for this graph. So I've got 14. If I distribute my -4 to my n and my -1 with this, so simplifying that, I've got 18 minus 4n, or -4n plus 18. And if you go back to your graph and think about it, if I went right there, that would be my y-intercept, and then my slope would be down 4 and over 1, so that makes sense. My second graph, I've got a sequence where my first term is 1, my second term is 8, and my third term should be 15. Sorry about that. Okay? So if you'll notice, I'm adding 7 every time. So if I'm adding 7 every time, then I have my first term of 1, my common difference of 7, and then I'm going to simplify. And I end up with 7n minus 6. So again, if I were to extend this, notice my y-intercept would be down here, so -6, and then a slope of 7. So sorry about that. That dot is in the wrong spot. Alright, so let's go ahead, and I'm going to make a second video for exponential, just because I think it would be easier than to have one really long video. So I'm going to go ahead and end this video right here.